literature of all of our different properties of logarithms. You don't even have to write this down if you don't want to, because these are already in your notes. Definition of a logarithm, that's what we just wrote up there. That means we do what? If I had log base b a equals x, how do we take that to exponential?
B to the exponent.
Right. Your base becomes the b, the base of your exponent, b to the x is equal to a. We're going to be doing this back and forth all day long. It's going to become your best friend. Okay, so converting from logarithm to exponential, converting back from exponential to logarithm. So I guess I should make my arrow go two ways, because we can go either way. All right, so that's our definition of what a logarithm is. Product property. Remember, if I had the log of x plus the log of y, how do I condense that to a single logarithm? Multiply, so it would be log xy. Very good. Doesn't really matter what the base is or what the x and the y is. This is just review from section 6.4. Quotient property. If I had log x minus log y, to condense that into a single logarithm, it's going to be division, so it's log x over y. Power property. What's that one? Yeah, so if we had log, let's say, x squared, that would be equivalent to 2 log x, or vice versa. If the 2 was out in front, we would take it to the exponent, right? All right, remember doing all this fun stuff back in section 6.4? Yeah? All right. So those will have to come back into play in our logarithm equations. Count to 10 in my head. All right, let's solve some equations. Are we ready? Let's do it. I love solving log equations. We're going to skip all those. Here we go. First one. We've got log x plus log the quantity x minus 3 equals 1. Now, because I'm starting out as a logarithm, to solve a logarithm equation, we have to do the inverse, which means I'm eventually going to take it from a logarithm to an exponential equation, which then hopefully we'll be able to solve. Before I can do that, I need to condense my 2 logarithms into a single logarithm using which property?
The multiplication.
Yeah, the multiplication one, because this is a plus. So what the multiplication one says is I'm going to take this x and multiply it with the x minus 3. So that turns into log x times x minus 3 is equal to 1. So now I've got a single log on one side. Now, if you think back to what we did before, sometimes we were converting this to a log with the same base, right? My base here is what? 10. So this would, a 1 would be equivalent to log base 10, 10. But my brain doesn't think like that. And I find it a lot easier just to go right from the logarithm to the exponential. So what's the base here? It's 10. It's going to turn into 10 to what power?
1.
To the 1. Remember? B to the x, b to the x. So 10 to the first power is equal to, let's go ahead and multiply that out right away. X squared minus 3x. Well, that doesn't look half that bad. It's a quadratic. Good thing last chapter we learned lots of ways to solve quadratics. 10 to the first power
10.
is 10. So I'm going to subtract that 10 over right away. So now we get 0 equals x squared minus 3x minus 10. Is that factorable?
Negative 5.
Yeah, negative 5 and positive 2, right? So factors of negative 10, that get us to negative 3, negative 5, positive 2. So x minus 5, x plus 2 is equal to 0. What are going to be my solutions?
5 and negative
5 and negative 2. Which one do I not like?
2. The negative 2.
Negative 2, because remember we can't take the log of a negative number. And if I put it into either of these, I'm going to get a log of a negative number. So that one does not work. It's extraneous solution, so we just go with 5. Okay, so if we're starting out as a log, think in my head I eventually want to take it to an exponential by using our flipping back and forth. Good with that one? All right, let's try this one. So we've got log of x plus 48 plus log of x equals 2. What do we need to do first?
Condense it into 1.
Condense it into 1. So what operation am I going to do with the x plus 48 and the x? Multiply. Good. So we get log of x times x plus 48. If you multiply it right away, that's fine at that point, equals to 2. So now I have a single log. If I had a log over here on this side, that would be nice, because then I could just take out the logs and focus on what's in with the log. But I don't. That's okay. So now we can take it from a logarithm to an exponential. My base here is 10, so it would be 10 to what power? To the second, equals, is everybody okay with me multiplying right away? X squared plus 48x. 10 squared is 100. Subtract that over. So then we get the quadratic, x squared plus 48x minus 100. Is that factorable?
Yeah. That's okay with negative 2.
50 and negative 2. Perfect. I like the way you're thinking. So factors of negative 100 to get you to positive 48. 50, negative 2. Which means my factored form would be x plus 50, x minus 2 equals 0. My two solutions are negative 50, positive 2. Don't like that negative 50, so we're just going to go with the positive 2. Okay, so we're going to go with those types. Good. If your base would have been a 2 here, then instead of 10, this would have been what? 2. So this would have been 2 squared, which means I would have subtracted 4 over, which then we would not have been able to factor that. We would have had to go with quadratic formula or completing the square, our favorite. One of those two to solve it out. Okay? So just think about whatever the base is for your base for your exponent. All right, what about if the x was in the base?
Can we just do the change of base? Oh,
No, we can't. So I've got log with the base of x, 1 over 128 is equal to negative 7. Do I have a single log already here?
Yes.
Yes, so we can convert right away from log to exponential. My base here is x, so that's going to become the base of my exponent. What's the power going to be? Negative 7 equals to 1 over 128. Oh boy, fractions and negatives. What can I multiply this exponent by to make it become a 1?
1/7.
Negative 1/7. Now pay close attention. I'm taking this whole thing to the power of negative 1/7 in my calculator. I'm not multiplying negative 1/7 and 1/28. This is a power. So these are going to multiply to get to just 1x equals, and then I'm going to grab my handy calculator, and I'm going to type in parenthesis 1 divided by 128, and I'm going to use my little caret, and I'm going to put parenthesis negative 1 divided 7, close it. What do we got? 2? So x is equal to 2. There it is. Brandon.
You could actually also pause my notes on that.
You could have. You could have. Okay. Like we could have done 1 to the 7th, 2 to the 7th, 3 to the 7th, and see which one gets us to 128. All right. What about if our x is nowhere dealing with log? So now I have x log 1/6 equals log 6.
Can you cancel the logs?
We can't cancel the logs.
Would the x be the exponent?
We could take it to the exponent, but then it's going to get even funkier. Make our lives even easier. What's the operation occurring here?
Multiplication.
Multiplication. What's the inverse of multiplication?
Division.
And what's so lovely about these logs is their bases are 10. So can't I just type that into my calculator?
Yeah.
So log 6 divided by log 1/6.
Negative 1.
Is it negative 1? So x is equal to negative 1. Okay. Which if you would have taken it to the exponent like Sarah suggested, so sidebar, we would have had log 1/6 to the x is equal to log 6. Then we could have ignored the logs and had the equation 1/6 to the x power equals 6. And doesn't that make sense? 1/6 to the negative 1 is 6, so it would just flip it, right? That's a little bit easier to solve it that way, if you can't see that. All right, can we get away from logs? What if we bring in the natural number? So now we have it in exponential form. Because I don't have a logarithm, I don't have a natural logarithm. I have e, which is my natural number. So since I'm in exponential form, that means I'm eventually going to want to take it to a logarithm. But since the base of my exponent is e, which specific type of logarithm am I going to use? The ln, the natural log, right? Because that's the log that has a base e. But before I can do that, I got to get rid of this 4 in front by doing what? Divide. Yep, so let's divide out the 4 first. 72 divided by 4, 15? 18. Okay, so now I have my exponent and power of this whole thing already by itself. So now let's think about, if you wanted to think about setting it up logarithmically, don't write this, just watch. I would write it as log base e, right? So my base is e, 18 equals 3x minus 5, right? But even easier, can't we just take the ln of both sides? So if I take the ln of both sides, now be careful right here, this ln and this e are going to cancel out. So you're just going to be left with the exponent of 3x minus 5 equals whatever the natural log of 18 is. I don't know what that is. 2.89. So we get 3x minus 5 is equal to 2.89. Now the rest is easy. Add 5 divided by 3. That's not easy? Come on, Ben. Yeah, 3x is equal to 7.89. Divide by 3, 2.63. I'm going to use these squiggles to show it's approximately 2.63. Okay, if we would have done it the other way, so I would have had log base e of 18 is equal to 3x minus 5. I could type this into my calculator. I would have to do the log of 18 divided by the log of, and then I would have to hit the e and then give it an exponent of 1, which probably gets you 2.89, I bet, if you did it in your calculator. But that's a little bit more technical, typing that stuff into your calculator, than just taking the natural log of both sides. Okay? Good with that? So far, so good? All right, let's do another one with e in it. So 7 times e to the 2x plus 2.5 equals 20. What's the first thing we're going to do? Subtract 2.5. I like that idea. 7e to the 2x is equal to 17.5. Divide by 7. So e to the 2x is equal to, give me a number.
2.5.
2.5. That's nice. Okay, so now that we got an e, right away I should be thinking I need to use that natural log. I need to use that ln. So let's take the ln of both sides. What am I going to get on the left when I take the natural log of e to the 2x? Just the 2x. Good. And then the natural log of 2.5 is what?
0.916.
0.916. Cut it in half.
0.458.
458. Sure. Okay. So when you see that e, that first thought in your head should be, I'm going to take the ln of both sides. But before I can take the ln of both sides, you have to get the e all by itself. Don't try taking the ln of this, the ln of this, the ln of this, the ln of that. That's not going to work. Get the e all by itself, just like we condensed the logarithm to everything by itself. All right, so we've got logs taking them to exponentials. We've got e exponentials taking it to natural logs. What if I had ln, the natural log, in my equation? So the ln of 3x plus 5 squared is equal to 4. Is that natural log all by itself? Do I need to do any condensing of anything? No. Okay.
Should we just take the log of e?
So we could just take the log of e. Is that what you said?
Yeah.
Yeah. So because I had a logarithm here, can I take it to exponential? What is the base of the natural log? E, right? The natural log is the same as log base e. Yes? So if I follow that formula, if my base is e, I'm going to take it to what power? E to the 4th. And equal it to what? 3x plus 5 squared. Ugh. 3x plus 5 squared, that's not fun. 'Cause that means I have to do 3x plus 5 times 3x plus 5. All right, I can handle that. 3x makes 9x squared. 15x makes 30x plus 25. E to the 4th, I do not know off the top of my head. It's 54 point, let's say 6. Yeah. Looks like I'm not going to be able to factor that one. That was my disgust with that 54.6. Let's subtract it. We know where this is going to go. It's going to get me in a singing mood here in a second. 0 is equal to 9x squared plus 30x minus 29.6. I know. Decimals. What's up with that? All right, here we go. X equals negative b plus or minus radical b squared minus 4ac all over 2a. All right. So because there's a decimal here, we're not going to be able to simplify this radical. That's not going to happen. So what I'm going to do is I'm just going to type this whole square root thing into my calculator at one shot. So I'm going to type in the square root of 30 squared minus 4 times 9 times negative 29.6. And I get 44.34, let's say. What did I say, 40? Whoa, what's that? Just, I don't know what that was. 44.34 divided by 18. All right, how do I get my solutions from that?
You have to do the plus one and the minus.
Yeah. So I'm going to do negative 30 minus 44.34 divided by 18, which gets me negative 4.13. Then I'm going to do negative 30 plus 44.34 divided by 18, which is 0.797. Which one do we think is probably not going to give us an answer? Yeah. So x is approximately 0.797. One more.
I have a question. though.
Yes.
With the beginning of it, we can just take the log of e and the log of e and cancel them out.
Yeah. And then we'll get you to the same equation.
Okay. Okay.
All right, last one. Are we ready? The natural log of the square root of x minus 3 equals 1. What do you think we're going to do first?
Add the one.
Add the
add
3 to the 1. Yep. So the natural log of the square root of x is equal to 4. Now I've got a single logarithm. This just happens to be a special one, just like the common log is a special one. This is the natural log. So I'm going to take e to what power? E to the 4th. Man, that seemed to occur often. Equals the square root of x. What do we say e to the 4th was? 54.6 is equal to the square root of x. How do we undo a square root? Square both sides. So 54.6 squared. Whoa, that's a big number. 2,981.16 is approximately equal to x. Okay? So, if you see an ln or an e, you know you're going to have to be doing an e or an ln to do the inverse of them. If you're starting out in a logarithm, get it to a single log, convert it to exponential form. If you're given just the plain old exponential form, convert it to a logarithm form. All right? So make sure you get